Innovation and slow industries, especially federally regulated ones, don't always go hand in hand. In heavy manufacturing, we have very large components and assets. So when we move something, it's very expensive, and we want to make sure that we're accurate. Let's go in, let's create a high fidelity digital copy, and then let's try to augment the processes that allow manufacturing engineers and engineering facilities management to copy and paste things around the facility. How could they delete an entire product line and then bring in models and be able to put something else in play? This is a very high value augmentation to our work process. We can mock up a product line in minutes. And if you have the ability to simulate your decisions and see the outcome, you're going to make a better decision. A digital twin is not a digital twin if it doesn't have good data enabling it. And if you have good business intelligence behind your digital twin, then your digital twins will be significantly more valuable to the business. If any of you are familiar with manufacturing, continuous improvement is the bread and butter of how we do things. If you oversell digital twin, you get funding to do all these things. If you're not patient and you don't operationalize it well, all it is just new tech. You just created a really cool model. Here's really the question. How might we leverage a digital copy of our facilities to augment engineering and facilities function, saving us time and money when reconfiguring or relocating operational assets? This is not the pursuit of the unicorn. This is a very strategic question where we're asking, can we take an incremental step forward to start to develop new internal capabilities to enable something that may help us transform? My name is Nick Hughes. I work with a Amsted Rail manufacturing company. We make a lot of the components that you see underneath of a rail car. So brakes, wheels, large castings. We still take steel, melt it, put it in the sky and pour the lava into a mold to make things. So an older industry, but a very technology forward and data rich business. I'll talk to you a little bit about our digital twin initiatives, but I want to talk about digital twin for manufacturers as a whole. I think being a manufacturer in this space, I think I'm the only manufacturing person here, but I think there's some insight that could help you. If you are one of those entrepreneurs working in reality capture, it might give you some insight into ways that we are thinking about twins and ways that you could potentially engage with us. We started in a weird place. I manage emerging technology, and so in our spatial computing initiative, we were on LinkedIn. We usually take a year or so to gain some footing, learn a little bit about the industry, and so we followed Jonathan Stevens and Michael Gula, and we ended up beginning with neural radiance fields. And anybody in here know what NERFs are? Yes, at least a couple. Awesome. We take 2D images around an object, and it can create a 3D point cloud, which you see there. Mine's very rough, but we accomplished something. So we ended up kind of backing into digital twin. It wasn't on purpose. It just happened to be something that we saw on a thread and said, "Oh, hey, let's think about this." So. That's how we got started, and I'll talk about our industrial transformation strategy, Industry 4.0, 5.0, digital. There are a lot of terms for what that is. Really, what it is it's our business strategy and our technology strategy paired together. So our mantra, as you can see up here, is start small, go fast, and fail cheap. And NERF really fit the bill for that. We didn't spend any money. We learned that you could take 2D images and create 3D experiences, and it was very easy. It didn't take a team to be able to do some of these things. So NERFs were honestly kind of a blessing in disguise. The return on investment for the way that we look at that strategically, especially for digital twins, it's a long play. We're not investing to see a quantifiable return within 12 months. It's transformative. It touches a lot of parts of the business. It's going to be hard to operationalize and scale across an entire enterprise. So something to keep in mind. It is a big disruption, as I just mentioned, and we're a slow industry. We're in transportation. That's federally regulated. There are a lot of organizations that have a lot of input and when you're creating new components or changing standards across the industry. So, innovation in slow industries, especially federally regulated ones, don't always go hand in hand. But there is a really strong compounding effect for transformative technology. So, as Merritt was talking earlier about being in the artificial intelligence space, we started in spatial computing. And spatial computing helped us get through COVID with remote assistance. That was just a very easy win for us. We started to expand that a little bit, and now we have crane simulators in virtual reality. We have lift truck simulators in virtual reality. So, our employees play video games to train, and that concept is pretty well adopted. And if you pair spatial computing with digital twin, and you think about the integrations, it's not this plus this equals, those two values. It's this times this, and that happens over and over and over, and they become exponentially more valuable when you can tie those technologies together. So there's the compounding effect as a part of our strategy there. And then all manufacturers are chasing the same unicorn. It's the digital thread. How do we go from a widget or a product or a process or a person and collect the data point, and then at the end of the day, process it through models, business intelligence, digital twin, however, right? It goes to a very long process, and then at the end of the day, we deliver insights to employees, or we deliver smart intelligence that can be weaved back into automation so things self-heal, right? There's the digital thread, and we'll talk about that a little bit. With our digital twins, right now we have this broke apart into three steps as a business. The first being digital models. When we talk about digital twin, we're not actually talking about digital twins. What we are talking about is digital model, and that's reality first, right? So as built, we go in, we scan, we create the facility, and that's traditionally what we've done up to this point. We have nearly 20 full facilities across the globe. And that has been all pretty much done with an RTC 360. So we've got pretty high fidelity, and then we mesh them, and that's how we operationalize. The digital shadow piece, that's what we are working into. That's where we're taking our manufacturing execution systems. We are extracting data and we're pumping it into the digital model so that we begin to be able to see operational data stacked on top of those meshes. The digital twin that's the dream of grandeur, right? That's where we want to end. That's a full cyclical process. That's where the twin and real life are both exchanging information instantaneously and integrated with other business intelligence pieces. A couple things that I would love to share with you guys. One, be patient. If you go out and you buy the first thing that you see and you partner with the first person that you find, you're probably going to get pigeonholed into something. You heard us talking about diversifying portfolios or in the previous conversation. It's not one headset rules them all. It is maybe a RealWear solves a problem here, maybe a HoloLens solves a problem here, maybe FaceTime solves the problem here. And I think the same goes with partners in the reality capture space. VLX isn't necessarily going to give you the quality that RTC will, but the TC is going to take significantly longer to scan. So be patient and find good partners in that space. Uniquely, we have scanned about 4 million square feet of our facilities, but we do it internally. So we reached out, we said, hey, we want to learn. Please teach us how to be able to capture reality, what tools do we need, and then we developed that capability internally. As a business, I think that we like to do that so that we can understand the brass tacks of something. It makes us more educated, so when we do partner, we know specifically what we're asking for. Admittedly, even with 4 million square feet of facility scanned, I just learned what survey control was in the past 30 days. And I really didn't know what it was until this conference. So as a business person who's not in reality capture or survey, appreciate the knowledge. I can see where we might have a bit of a risk there. But as you can see in the video on the left, this was the very first facility that we ever captured. This has no survey control. We had, literally a week of Googling to figure out how to use the RTC and a little help from a company called Real. And it turned out okay. We meshed it. So this is something that we still use today. But really our expectation was, let's go in, let's create a high fidelity digital copy, and then let's try to augment the processes that allow manufacturing engineers, engineering facilities management, those different kinds of internal organizations. How can we augment their workflow so that they can copy and paste things around the facility? How could they delete an entire product line and then bring in models and be able to put something else in play? And so that's where virtual commissioning comes into play. This is a very high value augmentation to our work process. In heavy manufacturing, we have very large components and assets. Arc furnaces, we have CNC machines and lathes. We have, what else? Presses that are half the size of the stage. So we work with railroad. Those components aren't small. We're not doing much of anything that's delicate. So when we move something, it's very expensive, and we want to make sure that we're accurate. But if you have to move it a second time, even if it's a couple inches, that's a big cost. Not only is it a big cost, but it generally requires a lot of equipment to be brought in to be able to move those kinds of objects. So what we can do now with this mesh model is import from Sketchfab, TurboSquid, whatever 3D library that we want, whether those models are animated or not animated, bring them into the space, and with, I would say, roughly 10 to 15 millimeter accuracy across the entire facility, even with no control, we can mock up a product line with models and such in minutes. And that's a lot different than what it was like previously. Previously, you hop into CAD, you find the drawing, if it's digital, if you're lucky. But being a 150-year-old manufacturer, that's not always the case. And then we design all those things in 2D. There's the whole big argument. I see that you've joined us, right? So Michael will tell everyone in here, 3D makes sense. 3D that's how your brain works. It just understands it. So, and we feel the same. If you can look at a press in a manufacturing facility and you can walk around it and it's virtual and you can see its geometry, your brain understands it better. Not to mention, these 2D drawings aren't always as accurate as we think that they are. So I'll talk about two differences. These are the two types of twins. We are focused on 4, but we believe that the 2 that are going to add most benefit to us are the sim twin and the op twin. And I would say most manufacturers feel the same. You talk about Exxon sitting right beside me. They've already accomplished a lot of this, right? So I'm not talking about the industry leaders in that space. I'm talking about the bulk, middle, in between. Simulation twins, we already have these. Operational twins, we already have those. Our operational twins are in 2D. Our simulation twins are in 2D. And they are not, I'll use the term gamified. They do not function and operate in the sense like a video game would operate to give you the simulation of activity. Sim twins are great for us because we can say, I'm going to increase the amperage on a conveyor. You heard me use the example earlier. I'm going to increase the amperage on this conveyor to speed it up. What is the outcome? Where am I going to catch my next bottleneck? Is this going to give me the throughput that I think that I need? A simulation twin also works primarily on happy path, and you can add some deviation for, I know it's going to have 2 failures every hour. You can add in some threshold like that, but it's not dynamic. It doesn't actually reflect what's going on in your operation. But the sim twin does allow us to make significant changes and simulate that over the course of 30, 60, 1,000 days, and be able to have a little more data supported decision making. The operational twins that we have today, they scrape data from our operations and extract it out of our manufacturing execution systems, our MES, and they bring those into the assets that we have connected them to visually in 2D, and we can create pretty good operational twins that have a visual representation of what's happening. So if you have a conveyor line, we can see widgets moving along a conveyor or processes happening at different places in different product lines. If you think about the two differences though, the massive benefit, right, this is that compounding effect. You get the benefit when those are paired together. So your MES data pops up and it says, problem A is happening. And if you have the ability to simulate your decisions, whether one or two, and see the outcome, you get a more contextual, you're going to make a better decision. I mean, it's apparent, right? It's a very obvious thing. That today we joke when we're talking about scrap, right? So we're pouring a train wheel and we're talking about, how do you know if this wheel is going to be scrap? Well, a lot of times, and if any of you have ever been in a factory, you say like, well, that's Tom. He's been here for 48 years. He can smell it and tell you if it's right. It's the gut feel. It eliminates that. You need some intuition, but at the same time, data supported decisions are going to be more accurate over time. Now, both of these are a part of our digital twin strategy. Our larger strategy incorporates 2 additional twins, which I'll talk about here in a minute. But both of these are precursors for really good business intelligence. And a digital twin, this goes back to that model, shadow, and twin. A digital twin is not a digital twin if it doesn't have good data enabling it. And if you have good business intelligence behind your digital twin, then your digital twins will be significantly more valuable to the business. As for the twins and data integration, all of the data that we pump into these twins needs to be focused on the consumer. The user experience of the digital twin and the data that they're going to consume out of it, it all has to be focused on the person. If it's not, then why would you be creating a twin in the first place? So the goal needs to be to augment someone's current function so that they can see and perform activities that they do today using the twin in some method. And the twin, I think the twins at the end of the day will probably be the single point of truth for most asset, supply chain, operational, and human data across an organization. And I say that because it is a modality where you can deliver data in a visual way. And graphs and charts and all the other analytical things that we traditionally use are great. But when we get to this hyper-connected point, I think that some kind of gamification of the data is going to be very beneficial for the speed of consumption. So just a quick note before we get off this slide. The 4 twins I'm talking about are digital twins, which is kind of the overall concept, but enabled with data. Product twins, operational twins, and people twins. And they aren't always completely integrated, but they're 4 independent things, and we think about them that way. People twins, we generally try to think of how can we scrape metadata or IoT enable our people so that we can make sure they're in the right place at the right time, not to make sure that they're working all the time, but to make sure that they're not going to be in the path of a crane operation, which is carrying a full ladle of steel. Operational twins we've touched on. Product twins are we think of those as any product that you buy today that's smart. IoT enabled usually gives you some kind of app where you can interface with it too, right? So for us, that's a product twin. And design twins are that digital model, which is what we use today to accomplish virtual commissioning. And here's why Twin is hard. Twin is hard because it requires earlier we were just talking about this. It requires a workforce change. It requires an educational component. It requires the data foundations to be there, the data quality, the data structure and control. Your tech stack changes. You can read the rest of them. What we found very quickly was if you want to operationalize a digital twin, it requires a change in your core process. So we go process, we collect some data, we get notified on something, we get a report on something, and then we change process. That's continuous improvement. And if any of you are familiar with manufacturing, continuous improvement is the bread and butter of how we do things. And then you repeat that process. However, it takes like 7 days. I mean, usually it's like a Monday morning meeting or something, right? In digital manufacturing and how that's different, process and data, those two things happen with machine learning, or I think everybody kind of envelops it with artificial intelligence. You're able to capture that data and provide an inside out where you could then, if your digital twin's enabled, that sim twin simulates, you either make an automatic process change or and that model gets trained, or you can even issue a notification of some sort using a people twin and be able to get an intervention that then is ran through the feedback loop, retrains. But that's instantaneous. If that's not seconds, that's minutes. And that's a significantly different change I think for any business, right? The note on here, really, be patient, because if you oversell digital twin, you get funding to do all these things. If you're not patient and you don't operationalize it well, all it is just new tech. You just created a really cool model. And my last slide here, here's really the question. This is what we asked ourselves. How are we going to leverage, or how might we leverage a digital copy of our facilities to augment engineering and facilities function, saving us time and money when reconfiguring or relocating operational assets? This is not the pursuit of the unicorn. This is a very strategic question where we're asking, can we take an incremental step forward to start to develop new internal capabilities to enable something that may help us transform? And I got to give some love to our partners here. I'm not sure if Real or Preview are in your guys' space. However, I will tell you that they are absolutely exceptional strategic partners. Real, Derek Dubois does a really good job helping us out with our scanners. Preview 3D, I just hold Preview on the second floor. Preview 3D is what we issue our reality capture to. So they actually take the point cloud and mesh it for us, and then provide the hosting and sharing. So and they've been really good partners for us as a manufacturer, trying to learn how to build this capability internally. So and then of course RC and all of you guys, right? How else would I have learned about survey control? With that, that's all I have for you guys today. Appreciate the time.